Hello, geometry folks. Welcome to 9.6. We are closing in on the end of Unit 9, and then it's a very, very short Unit 10, and that will be the end of Geometry B. So now we're taking a little bit different view here. Spheres kind of play by their own rules. They're not really like cylinders. They're not really like cones. They're not really like prisms. They're kind of an entity to themselves. So let's kind of take a look at kind of what we've got here. We've got, some terms you're familiar with: radius, chord, tangent, diameter. Those things you should know. Poles basically mean complete opposite ends. Think North Pole, South Pole. A great circle would be the circle around the largest part of the circle. So your poles would be like the end points of the diameter of a circle. A chord that contains a center, that would be your diameter. Segment that connects any 2 points in a sphere would be a chord. The segment from the center to a point on the sphere is the radius. The intersects the sphere at one point would be your tangent. And a plane that intersects the circle at the center would be your great circle. So that's kind of what you're looking at. So radius is exactly what you would think. Chord is what you would think. Diameter, tangent, all those things are the exact same. So now, when you find the surface area and the volume of a sphere, I'll give you the formulas first, and this is what should go down on your note sheet. Okay, so the surface area of a sphere is nothing more than 4 pi r squared. Okay, why 4? Well, let's consider this. Pi r squared, I hope you recognize, is just area of a circle. So now for a sphere, if we look at a sphere, so if we're just looking at just that side, we can see one circle. Then if we look at the back side, we can see another circle. Then if I look from the top and the bottom, I see 2 more circles. Between those 4 circles, I see the entirety of the sphere. I see every little piece, every little part of the sphere. So that's why I can consider that it's just 4 pi r squared. Now, volume, I won't get into too much of an explanation of volume. Volume is 4/3 pi r cubed. I know it's just a very, very random formula, but what it has to do with is the relationship between the volume of a sphere and the volume of, if I had a cube that fit perfectly inside of this thing and touched on every single side, on all 6 sides, the relationship between that, so that would be just 2r times 2r times 2r. That would be the volume of this cube. Okay, so that would be 8r cubed. So that's where the r cubed comes in. But then we end up manipulating a little bit, and it becomes 4/3 pi instead of 8. Okay, so that's the relationship between the sphere and the cube that would encompass it. Okay, so I would have a cube with a side of 2r, so 2r times 2r times 2r, but for the sphere, it would just be that. So a lot of this is in the setup, and after that, it's just a fair amount of calculator mashing. So this one, so 4 pi r squared, so 6 squared times pi is going to be 4 times 113.097. So multiplying by 4, it's going to be approximately 452.389 centimeters squared. Okay, so you're just 4 pi r squared, r is 6, so a little multiplication, area, surface area, that's what you've got. Surface area here, I'm saying that my diameter would be 22, which means my radius is going to be 11. So my surface area, 4 pi r squared, 4 pi 11 squared. So 121 times pi. And my answer will be 1,520 88.53. And it's good to label squared. Okay, nothing too brain break. Sure I did that right. Surface, nothing too bad. Find the surface area if the circumference, hold on. Okay, surface area if the circumference of the great circle is 5 pi. So circumference, remember, is just diameter times pi. So we know that that is 5 pi. So if we divide by pi, my diameter is 5, which means my radius is 2.5. Okay, remember, diameter just divided by 2 gets you your radius. So now they want the surface area. So that's going to be 4 times pi times 2.5 squared. So you want that times pi times 4, and you should get about 78.5398 meters squared. Okay, that's your surface area. That's it. So find the surface area of a sphere if the area of the great circle is approximately 130. So the area, we're talking about this area right here, so it would be pi r squared equals 130. And then we're trying to work back to our radius. Okay, so remember the area of a circle is just pi r squared. So I want to divide by pi. So radius squared would be about 41.38. So then you take your square root, and your radius should be about 6.43. Okay, so now for the surface area, 4 pi r squared. So I'm going to square that back times pi times 4. And that's going to be 520 inches squared. And that's it. And that's it. And what you might have noticed is that pi r squared equals 130. That matches up to up here. And so all I really needed to do was multiply by 4. That would have got me my answer. That's kind of it. So volume of a sphere with a great circle circumference of 18 pi. So the great circle circumference, remember circumference is diameter times pi, and we know that that is 18 pi. So when I divide, diameter equals 18, so my radius will just be 9 centimeters. But I want the volume. The volume is 4/3 pi radius cubed. So 4/3 pi 9 cubed. So 9 cubed is 729. And so now there's a couple different ways you can do it. You can put it all into the calculator at once. I know a lot of students will go those two, multiply those two first, and get 972 pi. So it's kind of up to you what you feel comfortable with. You can kind of get away with just calculator mashing, throwing that all in at once. But I would put parentheses around that so you don't get everything tripped up. But my final answer will be this. So I'm multiplying that first and then multiplying it by pi to get my answer. Okay. But like this one's a lot of setup and then calculator mashing. For a hemisphere, which is just, half of a sphere, volume actually makes a little bit more sense to me. So this would be the volume of a full sphere. And so for a hemisphere, you're just taking half of that. So all you're doing is saying, well, okay, half of that. Well, 4/2 is just 2. So my formula for that is r cubed. Okay, my formula for that is r cubed. For a surface area, the surface area actually, instead of 4 pi r squared, it becomes 3 pi r squared. I know, you would think it's just divided by 2, much like the volume, but it's not. Here's why. So you would see this one would just be one perfect circle. Then you got to realize you would have the top, which would be a perfect circle. Then if you look from both sides, you would see half a circle, half a circle. So you'd see 1, 2, half, half. That's where you get 3 pi r squared. Okay, so that's why it's 3 pi r squared, not 2 pi r squared. Okay, so make sure that this is in your yellow sheet. So surface area, much like before, a lot of calculator mashing. You don't have to, once you kind of get your setup, you can, just let your calculator do a lot of the legwork. So 2.8 squared times 3 times pi, if I just let all that go, I get 73.89 centimeters squared. And that's kind of it. That's kind of it. This one's a nice little break after some of the other ones, like cones and pyramids and things. So volume of the sphere. So here, remember, I want 2/3 pi r cubed. So I want 2/3 times pi times 6 cubed. So 6 raised to the 3rd power. All right, times 2/3 is going to be 144 pi. So multiply that by pi, you get approximately 452.389 meters cubed. And that's kind of it. That's kind of it. All right, that's kind of it. Nothing too terrible. Okay, so if we look, the volume of this massive stone sphere that they found in Costa Rica was 113,097.34 inches cubed, and that's a volume. So pay close attention, because this solving this one requires a little bit of making sure you know what you're doing in algebra. So what I'll do first is I'll get rid of the 4/3, and I'll do that by multiplying by 3/4. Okay, so 4/3 cancels out, the 3's cancel out, the 4's cancel out. So 113,97.34 times 3/4 ends up being 848.23. All right, and it actually kind of works out to that pretty close. So then I'm going to take my answer and divide it by pi. So then I get 27,000 equals r cubed. Okay, so now how do I solve for this? How do I do this? I can't take a square root. That doesn't work. Okay, I don't want to do that. What I end up wanting to do is pay attention here, take the 3rd root. That's a 3. Take the 3rd root. So how do I do that in a calculator? Well, what I will do is I will take the 27,000 and I will raise it to the 1/3 power. Okay, so I will take my answer and I will raise it to the 1/3 power, and it will equal 30. So now that will be r, so my radius would be 30 inches, but they want the diameter, so last step, multiply it by 2, that will be a 60-inch diameter, so about a 5-foot diameter of this massive stone. Okay, that's it. Please come talk to me with the questions. Make sure you get those formulas in your yellow sheet, and I will talk to you very soon.